So hello guys, today we are gonna solve another CSES problem and it is from graph section. The question name is Labyrinth. In this question we are given a map which is called as Labyrinth and our main task is to find the path from start to end. We can move left, right, up and down. Okay, that's fine. So basically in this grid what we need to do is from the start, which is A, we have to reach to the end point, which is B. We can move left, right, up and down, but we can only go in the dot cell. We can't move to hashtags, right? So we have to first move left from A, then down, down, then right, right, and right. After that, we have two choices. That is, we can move to up and right. After that, we have to move right and then up to reach to the B. And we have to return that if we are able to reach to the end. If it is yes, then we have to say that what is the minimum number of steps which is required to reach to the end and what is the path which you have taken. So after studying the question, one thing which should come to anyone's mind is we have to apply the BFS algorithm because it is the algorithm which we should use when we have to find the shortest path into a grid. We have to traverse it and find the shortest path. So yes, that's it. So let's try to write the code as well for the same, and if there isn't any path we can just return no. So let's first take the input. Let's call it int nm and let's take it scene of nm. Let's try to store the input into a string, vector of string of size n. We have to use a variable string as, and we can just mark it as input of I equals to s. Great, we have taken the input. Now what we need to do, a BFS, there are mainly 3-4 steps which we always need to perform. That is, first of all the starting point, if in this question there is only one A, so we have to only push current starting point into the queue data structure, and after that we have to move into its neighbors, and whenever we insert the neighbor into the queue, what we need to do is we have to check it is valid or not. If it is valid and if it is a valid path, we can just insert it into the queue. Whenever we find the endpoint is reached, we have to just exit it out. So that's main funda of queue data structure BFS algorithm. So here also we will try to do the same. So let's take it queue of pair int comma int, but it would be hectic to write whole thing again and again. So let's just say we are using PII as pair of int comma int. Nice. After that we have to insert the starting point into the queue. So let's do it right away. J less than m, J plus plus, and okay, mistake. Okay, if our input of I comma j is equals to a, so at the time we can just say that q dot push of I comma j, right? Also we can keep track of visited, so vector of vector visited of size n comma m, boolean, and everything is marked as false initially. After we visit it, we can just mark visited of I comma j as true. And what we can do is we can just store the start and end points beforehand only. So if further at any position we require it, we can just directly access it, right? Else if input of I comma j equals to b, we can just store it in end variable. That's nice. After that, this question, what we have to return is the path as well. So what we can do is, every time we move to some new column in the BFS, let's say from here we go to this, so here we will store the path where we have come. So this is, we have moved to the left direction from initial position. After that, here we can store d, similarly d, uh, here sorry, r, and if we go here we have to store up, here we can store r, and here u. So that's how we can store the whole path array. So we require a 2D grid again, vector of vector which will store characters. Let's call it path of size m comma, initially everything is dot. So let's try to write the BFS function while q is not empty. What we can do is we can take x comma y as q dot front, and then q dot pop. Now we have to traverse to its neighbors, so I less than 4, I plus plus. To traverse to its neighbors we require two arrays, dx which is of size 4, and similarly dy of size 4, 0 1 0 minus 1. Also we have to store the direction from which we are coming. So -1 comma 0 is up, 0 comma 1 is r, 1 comma 0 is down, and 0 comma minus 1 is left, right? 0 in the x and -1, yes, left. Great. Now our new x comma new y would be current x plus dx of I. Same ny would be n plus dy of I, and we can say if it is valid and nx should be less than n, ny should be greater than equal to 0, ny should be less than m, and our current input of nx comma ny should be equals to dot, or we can just say shouldn't be equals to hashtag, then, and it shouldn't be visited as well, right? If it is previously visited, that then there is no point to go again. Then we can just insert it into the queue, and y we can mark it as visited. Okay, and then yes, that's it, I guess. We have inserted into the queue, mark it as visited. After that it will do, also we have to store it into the path as well. How can we forget that? And we can just access it by using this direction of I bins. If we have came from -1 comma 0, that means we have gone to up direction. Similarly for all of that, so you can just use this trick in your many questions to solve it. Also we have to apply this BFS until we reach to the end, right? So if our new position where we have reached, that is if nx comma ny is equals to end then we can just break out. So we can keep track it using boolean variable if end is found or not, right? So here we can say end found equals to true and break out from the for loop. No need to further find any direction. And here we can say if we have found the end, or we can just directly write it here as well. If end is found, then no need to worry, you can just break out. That's cool, I guess. After that, I don't think there is this nx comma ny can be written like this, so we have to make a pair like this, nx comma ny, and okay, cur is equals to end, then we can just break out. Yes, I think it should make the path grid successfully. Let's try to print it out to check and debug if we have make any mistakes. C out of path of I comma j, and just do this. Yes, it is perfectly fine. Means from here we have moved to left, then down, down, right, 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 up, up, right, and right, right, up. So we have found it over here, so we haven't moved further from this call. That's completely good. Our code is fine till now, and we can just write that if end is not found, then there is an issue. So end found is false, then we can just say we haven't reached to the end, return no. And if we have found the end, then we have to backtrack from this point till we reach the start. So what we can do is, let's create a cur variable, and initially we can start from end. While cur is not equals to start, we have to find our answer. So let's call a output string initially empty. Whatever is this current index, let's try to store it. Int x is equals to cur dot first, similarly y is equals to cur dot second. Okay. So current character ch would be path of x comma y, and output should include that. So output will add a u into its string. After that we have to reach to this position, so we can reach here by subtracting. Means earlier what we were doing, current index plus dx of I. So now what we have to do, from here we have to x minus dx of I will get back us to its original position. So int nx would be x minus dx of index that we have to move, and ny would be same, dy of that index. Here we need to find that what is the index. So if we reach over here as well, then our current would be upgraded to this one, and when we reach to the start we end it, right? Now we have to find that where we have to move. So what is the index of it? So that can be easily found. Means earlier we are at u, right? So we must have came from the down. So first of all, if we had using u, so it would be marked with -1 comma 0. Correct. So it is zeroth index of it. So if we have 0, so we can track -1 as well and 0 as well from it. Okay, got it. So what we can do, we have to just run a loop from I equal to 0 to 4. We can say that if current dir or phi is equals to the character that is our index, and just break out from it. I think that's cool. And after that, we are just storing our answer in this reverse fashion. So we have to just reverse our string, output dot begin, output dot end. That's how we reverse the string. And let's just print the answer. Means first of all we have to print this. After that, what is the size of our this, and after that we have to print the string as well. That's cool. Let's try to run the code. If it is working fine, means there are some errors. Okay, it is saying that I is overloaded, but we haven't declared it in the 68th line. Okay, dir of I is overloaded with no contextual type information. Let's call it some other variable. If it is causing an issue, I don't think it should. Dx of that index, but index is not declared, so we have to declare it first, right? If we run it now, yes, so it is running expected. So let's match our output with the original one. Yes, it is indeed correct. And let's try to make it like we can't reach. So if it returns no, then that means we are fine and good to go. Let's try to submit it. Okay, let's try to run it over here as well, just to be sure, and copy the input from here, paste it. Yes, it is running fine, but it is giving some warning, means we can't use auto. Okay, so instead we can just write q.first, and we can just store it individually. X is equal to this. Copilot is giving some suggestions which we don't require. I guess it shouldn't now giving any correct. So let's save it and let's try to submit it right now. Choose file, this one, upload, and let's try to run the code. Yes, accepted. So that's how we are gonna solve this question, and thank you so much for watching. Bye bye.